welcome to True Projects. In this video, we are going to explain about the project, which is multi-class retinal diseases detection using deep CNN with minimal memory consumption. Coming to the introduction, retinal diseases such as age-related macular degeneration and diabetic macular edema can cause vision impairment. Accurate diagnosis is challenging and often necessitates experienced ophthalmologists due to the complexity of identifying these conditions. The central objective of this project is to apply cutting-edge machine learning and deep learning methods to augment conventional diagnostic approaches for retinal diseases while also improving efficiency and accuracy in disease identification. The existing system refer to the current state of technology or methods used for identification and classification of critical diseases, specifically retinal diseases. This includes machine learning techniques such as artificial neural network, deep learning, recurrent neural network, AlexNet and ResNet. These methods suffer from high memory consumption due to the moving feature maps to the decoder, limiting practical use. Existing state-of-art techniques in retinal disease classification may not effectively handle memory, impacting performance. The project suggests employing a deep learning approach, specifically a convolutional neural network model for the multi-class classification of retinal diseases. Coming to the objective of this project is to propose a convolutional neural network model for multi-class classification of retinal diseases with efficient memory consumption. The project aims to address the high memory and CPU consumption issue in the feature extraction process of the unit model, which is commonly used for retinal disease classification. The proposed model is evaluated on the standard benchmark dataset of iNet consisting of 32 classes of retinal diseases, and the objective is to achieve high accuracy in disease classification while efficiently managing memory consumption. The project aims to compare the performance of proposed model with existing techniques based on precision, recall and accuracy, considering different numbers of epochs and time consumption. The significance of the project lies in improving the memory management and accuracy of retinal disease classification, which can enhance the traditional diagnostic process for retinal-based crucial diseases. To implement this project, we need hardware and software requirements. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8GB and above, and hard disk of 25GB and above. Coming to software requirements, we need Anaconda 3 and Visual Studio Community version. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. This is the initial step, involves importing essential Python packages and libraries that are crucial for various aspects of the project. We have imported NumPy for numerical operations, Pandas for data manipulation, TensorFlow for deep learning, Matplotlib and Seaborn for data visualizations, and Scikit-learn for machine learning. Coming to the next step, which is exploring the dataset. In this phase, the iNet master dataset, which contains a collection of retinal images, is meticulously examined. Data exploration includes tasks such as understanding the dataset structure, checking for data quality, and identifying the types of retinal images and their associated labels. This preparatory step is vital for gaining insights into the dataset's characteristics. Coming to image processing, this module is responsible for preparing the retinal images for model training and analysis. It involves the use of an image data generator, a tool for performing data augmentation and standardization. The specific process includes rescaling the image. This ensures that pixel values in the images are normalized, making them suitable for deep learning models. Coming to shear transformation. Shearing the images introduces controlled distortion, enhancing model robustness. Coming to zooming the image, adjusting the zoom level introduces variability and aids in better model generalization. Horizontal flip. Flipping images horizontally augments the dataset with mirror images. Reshaping the image. Images are resized and reshaped to align with the input requirements of the chosen models. Building the model. In this critical phase, CNN model is developed to classify retinal diseases accurately. Training the model. The models created in the previous step are trained using the preprocessed dataset. During the training process, the models learn to recognize relevant patterns and features within retinal images. This step is integral to the model's ability to accurately classify diseases. As an extension, we have built front-end using Flask framework for user testing and authentication. Coming to Flask framework, the Flask web framework is employed to create user-friendly web-based interface for the project. This interface serves as a portal for user interactions, allowing users to upload their retinal images and obtain diagnostic results. Coming to user upload and image for analysis, users are empowered to upload their retinal images through the web interface. This interactive feature enables individuals to have their images analyzed by the system. Image preprocessing, which is the given input is preprocessed. Similar preprocessing techniques as those applied to the dataset are used to prepare user-uploaded images. This step guarantees that all images are brought to a uniform format suitable for analysis. Coming for the next step, which is the train model is used for predicting the result. The heart of the system, this module applies the previously trained machine learning and deep learning models to the user's uploaded retinal image. This model uses the knowledge they have gained during the training to make predictions and classify any images or conditions present in the image. Coming to the last step, which is displaying the final outcome. The ultimate results of the analysis encompassing diseases classification and any relevant findings are presented to the user through the web interface. This final outcome serves to inform and assist users in understanding the analysis results. Algorithms used in the project are CNN. It is a convolutional neural network. It is a deep learning model that is designed for processing structured grid data such as images. CNNs employ convolutional layers to automatically learn features from the input data, making them highly effective in tasks like image classification, object detection, and segmentation. It is used to establish a foundation for retinal disease detection and provides a point of reference for other models. CNN is valued for its ability to learn features from images, making it essential in the context of medical image analysis. As an extension, we have built two more deep learning models and a hybrid model to produce more robust and accurate final prediction. So here we have comparison graphs. So this is the horizontal bar graph which represents accuracy scores of each algorithm. Accuracy is the proportion of correct predictions in a classification task measuring the overall correctness of a model's predictions. So in this graph, x-axis represents accuracy score of each algorithm and y-axis represents algorithm names. Similarly, we have precision score graph also. Precision is a ratio of true positive predictions to the total positive predictions, representing the model's ability to correctly identify relevant instances while minimizing false positives. Here we have recall score graph. In this graph also, x-axis represents recall score of each algorithm and y-axis represents algorithm names. Recall is also known as sensitivity or true positive rate. It is the ratio of true positives to the total actual positives, measuring a model's ability to capture all relevant instances. And here we have F1 score graph. F1 score is the harmonic mean of precision and recall, offering a balanced measure that considers both false positives and false negatives, making it suitable for imbalanced datasets. For execution of the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. Here we have templates folder. This folder contains all HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This file contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. And here we have a sign-up file. This is the database file used to store the user information. And here we have notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it popular choice for data science. Now we need to copy the code from code folder of the project. So here I am copying the code from the address bar. And now we need to open Anaconda prompt. Using the cd command, we need to paste the copied path. So I'm pasting the copied path. And now we need to click on enter. This will change current directory to the code folder's path. So here we can see that current directory is changed to the code folder's path. Here we need to type the command which is python space app.py and then click on enter. This will compile app.py file. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, which is the localhost and the port. Now we need to copy this local link provided by the framework and paste it in any web browser. I prefer Google Chrome, so I'll paste it in that. So here we'll paste the link and then click on enter. This is the web page of the project which is displayed in the browser. And this web page is built by using the Flask framework. So here first we need to click on register link. So I'm clicking on this link. Here we need to enter all the registration details if we are registering newly. I have already registered, so I'll directly click on click here link to log in. Here we need to enter our credentials, which are the username and the password. So I'm giving my username and the password. And now we need to click on login. We are redirected to homepage where we need to upload the retinal images. So I'm clicking on choose file to upload the retinal images. First I'm selecting the first image and click on open, and now we'll click on upload to upload the image. Based on the given image, it is predicted that the person is suffering from giant retinal tear. Now we will upload one more image. This time I'll select this image and click on open. So based on the given image, it is predicted that the person is suffering from adult foveo-macular dystrophy pattern. Now we will upload one more image. So now I'm clicking on choose file and I'm selecting this image, and now I'll click on open. So based on the given image, it is predicted that the person is suffering from age-related macular degeneration with pattern dystrophy appearance. Now we will upload one more image. I'm selecting this image. So based on the given image, it is predicted that the person is suffering from AMNR macular neuroretinopathy. Now we will log out. Conclusion of the project is: the proposed convolutional neural network model for multi-class retinal disease detection achieved an impressive accuracy on the iNet dataset. This demonstrates its effectiveness in accurately classifying retinal diseases while efficiently managing memory consumption. The model's performance was comprehensively evaluated based on various metrics including precision, recall, and accuracy. Different number of training epochs and time consumption were considered, ensuring a thorough assessment. The model consistently outperformed existing techniques in terms of memory management and accuracy. The deep learning-based CNN model strengthened the traditional diagnostic process for retinal-based crucial disease by improving memory management and achieving high accuracy in disease classification. It offers a promising alternative of conventional methods. The model's performance was rigorously evaluated by comparing the categorization results with label provided by ophthalmologists, reinforcing its accuracy and reliability. The project's primary objective of proposing a CNN model with efficient memory consumption and evaluating its performance on retinal disease classification was successfully achieved. The model's high accuracy and enhancements memory management makes it valuable contribution to the field of medical diagnostics.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.